Hello and welcome to Engineers Mindset Academy. So today we are going to be talking about a new series on Engineering Mathematics 5. Okay, so we are going to be doing integration on a complex plane. Now, let's say we are asked to integrate the function f of z dz. So this is actually a complex plane. In the first video or in the previous video which I did, we talked about analytic function, and we said in that video that always you consider f of z to be equal to u plus iv. Of course, this is what I'm going to be using all through the series. So always consider f of z to be u plus iv. Because we're talking about integration on a complex plane, that means it has to involve a complex number, and a complex number is a number that is mixed with a real part and an imaginary part, as can be seen here, u plus iv, where the I indicates the imaginary part of the complex number. So v here is the imaginary part since it contains I, and u is the real part which does not contain an imaginary function. And then we also said that z is also equal to x plus I y. So these are two things we are always going to be considering in or throughout our analysis on this engineering mathematics 5. Okay, so you're asked to integrate f of z dz. The thing that comes into your mind first is dz, the function dz. If you have z to be equal to x plus iy, it means that you can find what dz simply means differentiating z, and that is simply saying differentiate each of these terms involved in z. So dz becomes what? Dx plus I dy. So you have this to be what? Dz, differentiating x and also differentiating y. So you have dz to be equal to dx plus I dy. Now, aside that, other things you need to pay attention to in carrying out integration on a complex plane is actually complex numbers, because in most cases you have to multiply two functions together. For instance, we know that a complex number I is mathematically given as square root of minus 1. So it means that if I have I squared, it simply means what? I times I. So this is actually what? Multiplying root 1 by itself. So this becomes root minus 1 multiplied by root minus 1. This will obviously give us root minus 1 all squared. When I have two same numbers multiplying themselves, it's same as saying that number all squared. For instance, 2 times 2 is actually 2 to the power of 2, which is equal to 4. So the same thing happens here. Root minus 1 multiplied by root minus 1. This gives me what? Root minus 1 all square. So this square helps us to cancel what? This square root. So this actually means that I squared itself is equal to what? Minus 1. You also have to keep this in mind. So you might want to do a review on your complex numbers. Also, I cubed is actually what? I squared times I. So this is now equal to, I know what I squared is. I squared is what? Minus 1. So in place of I squared, I have minus 1 times. I also know what I is. I is root minus 1. So times root minus 1. So which means that this implies that I cube is equal to minus root minus 1, and so on. Okay, so you need to also do a review on your complex numbers. All right. To also further continue in integration on a complex plane, another thing you need to consider is the term. That's also a mandatory thing you need to consider. We have that y minus y1 all over x minus x1 equals y2 minus y1 over x2 minus x1. This is also what? This is the equation. You also need this equation to carry out any integration on a complex plane. Alright, so joining all of this together, you can fall back to this original equation when you're asked to integrate this given function f of z dz from a particular point to another point on a complex plane, you can now join everything together. This becomes now integral of f of z dz is now equal to integral. You know what f of z is? That is u plus iv, okay, times, you know what dz is. You've already done for dz and you obtain dz to be equal to this. You have the x plus I the y. Now you have to now expand this function and then you start solving from there, employing every other thing, the idea of the complex number, the idea of the, and then you can solve from there. So let's pick a real example to explain the whole of this concept. So let's say we are given to integrate this function from a11 to b28 along the first equation. The first equation says along the straight line AB, and then the second one says along the curve C from when x is equal to t and y is equal to t to the power of 3. So the first thing, of course, you set up your equation, you have to integrate f of z dz. Like I said, you have to integrate f of z dz, and I told you already that where z, okay, is equal to x plus I y, therefore we can actually find what dz simply differentiating this function individually. So dz becomes what? Dx plus I dy. I have this. Also, we are given the function already, f of z. We have f of z already to be equal to x squared plus I xy. Okay, you have this. So let's plug these two into the equation now. Therefore, integral of f of z dz is now equal to integral. What is f of z? F of z is x squared plus I xy. You put it down, x squared plus I xy, okay, multiply by dz, and dz itself remains dx plus I dy. So let's expand this bracket now and see. This now implies that we have the integral to be, okay, this is now equal to integral. Let's expand this bracket now. X squared multiplied by dx gives us x squared dx. X squared multiplied by I dy gives us plus I x squared dy. Also, ixy multiplied by dx gives us plus I xy times dx plus, now watch, ixy multiplied by I dy, I times I gives us I squared times, then you have xy dy. You have this. So this is equal to integral from x, okay, this is equal to integral x squared dx plus, okay, here we have I to be common between these two, so we can actually factor I into x squared dy plus xy dx. Now take note, we said earlier that I squared from complex number, I squared is equal to minus 1. So which means in place of this I squared, it becomes minus 1 times x y dy. So you have this. So this has been eliminated because I squared represents minus 1. So let's rearrange this equation now. Bring all the real parts together. You have this to be integral, okay? Mind you, this is integral of all the functions here, so you might want to put them in a bracket, okay? So this is now integral. Let's bring all the real parts together. X squared dx. I have x squared dx. I also have minus xy dy minus xy dy. So these are the real parts, plus also I have the imaginary parts. Okay, so the integral is for all, so plus I into x squared dy you have x squared dy plus xy dx. So you have this. Okay, so you might want to, of course, employ the idea or the rule, one of the rules of integration, which states that the integral of a sum is actually a sum of the integral. So this is actually integrating a sum, this plus this. So it means that this is actually what the integral of the individual what sum. Integral of a sum is a sum of the integral. Alright, so this is what it means. Okay, so that statement simply means that I can actually integrate them individually. It becomes integral x squared dx minus xy dy, okay, plus. Now you have to integrate the imaginary part separately. So you can integrate, pull out I, it becomes I integral of the imaginary part now, x squared dy plus xy dx. So I have x squared dy plus xy dx. So the equation becomes this. So this is what our statement means. Integral of a sum is a sum of the integral, since the whole of this imaginary part is summing with the imaginary part and you're integrating them. It means integrate the real part plus integrate the imaginary part. Okay, so not forgetting, the question says that we should integrate from a1 1. So let's put that our condition. We have to integrate from a1 1 to b2 8. So let's plug this down now. So this is x1 y1 and this is x2 y2. Let's make a rough sketch of this information. We have our graph. This is our y axis and this is our x axis. So it says at x1 the value is 1. So for x, when the value is 1, this is 1. When to locate a exists at x equal to 1 and y equal to 1. So this is also y. Let's call this y, and that's 1. So this is where a actually lies. So you have something like this. So this is where a lies. A lies here at 1 1. Next, to locate b, b lies at x equal to 2 and y equal to 8. So if here is 1, you can simply call here 2 for x, and then you can call here 8 for y. So which means to locate b is somewhere around here. Okay, this is where b lies when x is 2 and y is 8. So if I join these points, okay, let's say if I join these points together, okay, all right, so we are asked to find the integral along the straight line. That's the first equation, or the first question. It says find the integral along AB, line AB, and along line AB simply from here, from A down to point B. We are asked to find this integral along line AB. So you now recall your equation. Remember, y minus y1 over x minus x1 is equal to y2 minus y1 all over x2 minus x1. So let's plot this information in. Y is a constant minus y1. Y1 indicates what? The first value of y, that's from A, and the value here is 1. So you have y minus 1 all over x minus x1. X1 also the first value of A, which is 1, and this is equal to y2. Y2 means the second value of y in B. So you have it here. Y2 here is 8. So 8 minus y1. Y1 remains 1. Okay. All over x2. X2 is the second value of x in B. That's 2 minus the first value of x. X1 is 1. you have this. So y minus 1 all over x minus 1 equals 8 minus 1 gives us 7 all over 2 minus 1 is actually 1. So from here you can easily cross multiply the whole of this x minus 1 multiplies everything here 7, and the whole of this y minus 1 multiplies everything here 1. So you have y minus 1 to be equal to, okay, y minus 1 times 1, the whole of this multiply 1, and that's equal to the whole of this x minus 1 multiplied by the whole of this, which is 7. Okay, so from here I will have, of course, y minus 1 multiplies 1 still remains y minus 1, and this is equal to, expanding this bracket now, x times 7 gives me 7x, and 7 times minus 1 gives me minus 7. At this point, let y be equal to everything here. Simply send minus 1 over to this side of the equation. Therefore, you have y is equal to 7x minus 7 minus 1 crossover and equal sign becomes positive, so it becomes plus 1. So this simply implies that y itself is actually what? 7x minus 6. Keep this equation aside. Now, we are asked to carry out this integration from a equals 1, 1 to b equals 2, 8. And if you look at this integral, we are having mixtures x squared dx, xy dy, x squared dy, xy dx. So it means that it will be very difficult for us to integrate, since we are having terms in the x, terms in the y, and terms in the x and terms in the y. It will be very difficult for us to carry out this integration. So in order to do that, we have to now employ the equation of state to make y a function of x. Now, making y here, y is equal to 7x minus 6, which means y now depends on x. So, which means I can what? Find the y. Find the y. It now becomes a function of x. If y is a function of x, it means the y will also be what? A function of x. To make the whole of the equation function of x. So, in that case, that means that we are going to be integrating all through as a function of x. Or you can also choose to make x subject to the formula so that x will now become a function of y, such that if you differentiate x, you have to now have it in terms of what? The y. To replace every other function of the x has to be what? In terms of y. To carry out this integral all through in terms of y, you will still have the same result. So now we have y to be equal to 7x minus 6, which means y is a function of x. And as such, I can find the y. So from y equals 7x minus 6, this implies that the y is equal to differentiate, this becomes differentiate 7x. If I differentiate 7x, I will simply have what? 7 dx. Okay, and if I differentiate minus 6, it gives me what? 0. If I differentiate 7x, I will have 7 dx. That's simply what? Keep 7 and differentiate x, because 7 is a constant, so you hold it and you differentiate x. So the y is simply 7 dx. So if I know this to be my dy, it means now that anywhere I see dy in this integration, replace the value to be what? 7 dx. Automatically everything here will turn to be what? In terms of x. Then it will ease me to what? Carry out my integration. That's the whole idea on integration on the complex plane. It's as simple as this. So always keep your equation in mind. You must need it. Always keep it in mind, because it helps to what? Ease the integration. Alright, so this means now that anywhere I see dy, I will simply put the value as what? 7 dx in that equation. Let's evaluate it and see. So let's now look into this integration. We have integral of x squared dx, x squared dx. So I want all my integration to be in terms of dx. So I'll move on now. Minus xy minus xy. But after minus xy, we have dy. But we know that dy is actually what? 7 dx. So in place of dy, we simply put in the value as times 7 dx. So notice that everything here has now been in terms of what? Dx. Okay. plus I integral. Next is what? X squared dy. So you put down your x squared, but remember that dy is actually what? 7 dx. So in place of dy, it becomes x squared times 7 dx. Okay? Plus. Next is what? Xy dx. So you keep it like that. You have plus xy dx. Okay? So let's expand this bracket now. We have integral of x squared dx minus this becomes now 7xy dx plus I integral of f, okay, x squared times 7 dx becomes 7x squared dx plus xy dx. But it doesn't also end there. It doesn't also end there. We've also found out that y, remember it was asterisk here, y is equal to 7x minus 6. So we want all the terms to be in x so that it can be very easy for us to integrate. But y equals 7x minus 6. So wherever you see y in that equation, put in the value as 7x minus 6. Okay, so you now have integral of x squared dx minus 7xy, but y remains 7x minus 6. So this becomes 7x times 7x minus 6 dx. Okay, you have this plus I integral into, I have here 7x squared dx plus I have xy, but then again y remains 7x minus 6. So you have this to be what? X into y is 7x minus 6 dx. Alright, so I have this. Now let's evaluate all and see. This becomes integral into x squared dx minus, let's expand this bracket now. 7x multiplied 7x gives us 49x squared. Remember there is the x attached to it, so 49x squared dx minus 7x times minus 6, minus times minus is plus, so you find 7 times 6. So 7x minus 7x times minus 6 becomes plus 42x. Also not forgetting there is the x attached to it, the x. So you have this plus I integral. Let's also evaluate it. That gives us 7x squared dx plus, so we expand now, x times 7x gives us 7x squared minus x times minus 6 here gives us minus 6x. Okay, not forgetting x times 7x here is 7x squared, there is the x attached to it, so it becomes 7x squared dx. Okay, then x times minus 6 gives us minus 6x, not also forgetting there is the x attached to it, times the x. So the equation becomes easy and simplifiable from here on. Alright, so this is now integral, okay, into, let's add up now, x squared dx minus 49x squared dx. Okay, x squared minus 49x gives us minus 48x squared dx plus 42x dx. You have this plus I integral, okay, this is 7x squared dx plus 7x squared dx. That gives us 14x squared dx minus 6x dx. It's as simple as this. Now we need to integrate. Remember, we are integrating from A, which is 1 1, to B, which is 2 8. Now all these terms, everything under the integral is now in terms of x. So which means we have to integrate from where? X1 towards x2, because there is no term in y here. All integration is now in terms of x, so we integrate from x1 to x2, and x1 is equal to what? 1, down to x2 is equal to 2, from a to b. So that makes it what? Automatically a definite integral. All right, let's carry out that analysis over here. So it means now we are integrating from x1 down to 2, from x is equal to 1 down to x equal to 2, since everything here is in terms of x. So mind you, if you have gone the other way around by making x a function of y, then also looking for the x in terms of the y, to make everything here a function of y, that means if you're integrating, you have to now integrate from where? Y1 down to what? Y2, which is from 1 down to 8, and you will see obtain the same result as obtained here. So you can actually do that as an alternate solution to compare the both results if you're going to have the same answer. Okay, so we have integral from 1 to 2 of minus 48x squared dx minus 48x squared dx plus 42x dx, okay, plus I integral also from 1 to 2 of 14x squared dx minus 6x dx. Okay, you have this. So let's break down this integration now. You have this to be equal to integral or minus, okay, integral from 1 to 2 minus 48x squared dx plus integral from 1 to 2 42x dx plus I, okay, let's keep I multiplying everything, integral from 1 to 2 14x squared dx minus integral from 1 to 2 6x dx. Okay, so of course you all know the rule of integration. You bring out all the constants outside and integrate only the variables. So by so doing, we'll bring out minus 48. You have minus 48 integral 1 to 2 x squared dx plus bring out 42. You have 42 integral 1 to 2 x dx plus I, all into, also bring out 14, it becomes 14 integral 1 to 2 x squared dx, okay, minus bring out 6 integral 1 to 2 x dx. You have this. So we can now integrate. You have minus 48. If I integrate x squared, I will have x3 to the all over, okay, x to the power of 3 all over 3 from 1 to 2 plus 42. If I integrate x, I will have x squared all over 2 from 1 to 2, okay, plus I into 14. If I integrate x squared, same fate. Okay, let me change this to is, okay. All right, so it becomes plus 14 into, if I integrate x squared, I have x3 all over 3 from 1 to 2 minus 6. If I integrate x, I have x squared over 2 from 1 to 2. So we have this. All right. So I think we can pull out all the divisions, all the divisors. So we have minus 48 all over 3 into, this becomes x to the power of 3 from 1 to 2 plus this is 42 all over 2. Pulling out this, you have x squared from 1 to 2 plus I into, same thing, pull out 3 here, becomes 14 all over 3 into x cubed from 1 to 2 minus, this becomes 6 all over 2 into x squared from 1 to 2. Okay, you have this. Okay, let's now put in our limit. This is minus 48 over 3 into upper limit comes first. So I have 2 to the power of 3 minus 1 to the power of 3. So upper limit minus lower limit plus 42 over 12. 42 over 2 is actually 21. So we have 21 into putting the limit, upper limit comes first. You have here is x squared, so it becomes 2 squared minus 1 squared. Okay, plus I into 14 over 3. Alright, now you put in your limits. Upper limit comes first, so 2 to the power of 3 minus 1 minus here 6 all over 2 is 3. You have 3 into upper limit comes first. This is 2 to the power of 2 minus 1 to the power of 2. Anyway, this is also 1 to the power of 3, same thing as 1. And then you have this. Okay, let's evaluate 48 divided by 3. 48 divided by 3 gives us 16. So you have minus 16 into 2 to the power of 3 is 8. So you have 8 minus 1 to the power of 3 is 1 plus 21 into 2 to the power of 2 is 4 minus 1 to the power of 2 is 1 plus I into 14 divided by 3. 14 divided by 3 gives us 4.67 into 2 to the power of 3 is 8 minus 1 to the power of 3 remains 1. Okay, minus 3 into 2 to the power of 2 is 4 minus 1 to the power of 2 remains 1. You close your brackets. So let's do this all at once. 8 minus 1 is 7. 7 times minus 16. Alright, so minus 16 times 7 here gives us minus 112. Again, 8 minus 1 is 7. 7 times minus 16 gives us minus 112. Plus, same thing here, 4 minus 1 is 3. 3 times 21 gives us 63. You have that to be 63. Plus, I into, now you have 8 minus 1 is 7. 7 times 4.67. So 4.67 times 7 gives us 32.7 approximately. So once again, 8 minus 1 is 7. 7 times 4.67 gives us 32.7 approximately. Minus, here I have 4 minus 1 is 3. 3 times 3 here gives us 9. So I have this. So if you continue evaluating this, this is now equal to minus 112 plus 63. Okay, so minus 112 plus 63 gives us minus 49. Here as well, you have plus I. Okay, 32.7 minus 9. That gives us 23.7. So this is your final answer. Therefore, the integral of that function, integral of f of z, the z of that given function is simply minus 49 plus I 23.7. That's the final answer. Alright, so that is the first part of the question solved. The second part says we should integrate from a11 to b28 along the curve C when x equals t and y equals t to the power of 3. So we have to take back this equation to the original form of the equation before we started changing the values of y, before we started changing the values of the y to be 7 dx. We have to move it back to that point. So you have to actually do well to either you back forward to that point, or you can as well follow me here so we can bring it back to that exact equation before we can be able to solve. So you can either follow me or you can backtrack the video back to the point before I substituting the value of the y to the 7 the x, just to change everything in terms of the x. So but we can pull it back from here. This is now integral of x squared dx. Remember, this is xy dy that changed. It was the y that changed to 7 dx. So we can simply call that minus xy dy. Okay, minus xy dy plus I integral into same thing here. We have here x squared 7 dx, and dy was given to us as 7 dx. So this becomes x squared dy plus, and here we have xy dx. So this is okay, xy dx. So we have a new condition now. We are given that when x is equal to t and y is equal to t to the power of 3, you have to integrate along this curve. This is very simple now. This simply means that if x is equal to t and y is equal to t cubed, it means that y is actually equal to what? X to the power of 3, because x is equal to t, and I'm seeing t here. So which means in place of t becomes what? X. So y is actually what? X to the power of 3. Hence, wherever you see y in this equation, you put in the value as what? X to the power of 3. It's as simple as this. Then again, we need to also find what? Dy. Therefore, we differentiate y. Dy is equal to, if you differentiate y, you're going to have what? 3x squared dx. You have this. So wherever you see dy in this equation, put in the value as 3x squared dx. It's as simple as that. So let's put in the values now and see. The integral becomes integral of x squared dx minus, this is now x in place of y. Y is now what? X to the power of 3. Okay, times dy, and dy itself is what? 3x squared dx. So you have 3x squared dx. Close your brackets. Okay, so you have this plus I into integral into same thing. I have x squared dy. This is now x squared times, what is dy now? Dy is 3x squared dx. So times 3x squared dx plus I have here xy, now x, but y itself, y is what? X cubed. So this becomes x times x cubed. Alright, xy dx times the x. So you have this. So let's evaluate all now. This becomes integral into x squared dx minus x times x to the power of 3 gives us x4 times 3x squared here gives us 3x to the power of 6 dx. X times x cubed is x4. x4 times x 3x squared gives us 3x6 dx. Okay, plus I integral into same thing here, x squared times 3x squared gives us 3x4 dx plus x times x cubed gives us x4 dx. You have this. Okay, so you can now evaluate the integral separately. This becomes integral of x squared dx, because everything is now in the x, so you can evaluate them separately, minus integral of 3x6 dx plus I all into integral 3x4. Okay, I think something can go here. This becomes I integral. Now this is 3x4 plus x4. So x4 and x4 can add. this becomes integral of 4x for the x. So that can add, that can go. Okay. All right. Now recall you're integrating from a 1 to b 2 8. Same thing, since everything now is in terms of x, in order to turn this to a definite integral, it means we have to also integrate along the x-axis. So from x equal to 1, which is x1, down to x equal to what? 2, which is x2. So it becomes a definite integral. So this becomes now integral from x equal to 1 down to 2. I have this to be x squared dx minus, remember, take out all constant out of the integral sign. It becomes 3 integral from 1 to 2 x to the power of 6 dx plus, bring that 4 as well. I have I4 integral from 1 to the power of 2 of x for the x. Okay, so I can integrate x squared. That gives me x3 all over 3 from 1 to 2 minus 3 into, if I integrate x6, I have x to the power of 7 all over 7 from 1 to 2 plus 4 into, if I integrate if I integrate x4, I'll have x5 all over 5 from 1 to 2. Okay, this becomes 1 over 3 into x cubed from 1 to 2. Okay, I have minus, this becomes 3 all over 7. If I pull out the 7 out, it becomes 3 all over 7 minus 3 all over 7 into x to the power of 7 from 1 to 2 plus I4, okay, all over 5 into x to the power of 5 from 1 to 2. So let's put in the limits now. Upper limit minus lower limit. This gives me 1 all over 3 into upper limit is 2. I have s cubed here, so it becomes 2 to the power of 3 minus lower limit is 1, 1 to the power of 3 minus 3 all over 7 into upper limit. Upper limit is 2, so it becomes 2 to the power of 7 minus 1 to the power of 7 plus I 4 all over 5. Upper limit comes first. This becomes 2 to the power of 5 minus 1 to the power of 5. So I have this. Alright. So this is 1 all over 3 into 2 to the power of 3 is 8 minus 1 to the power of 3 remains 1 minus 3 all over 7 into 2 to the power of 7. 2 to the power of 7 gives 1, 2, 8 minus 1 to the power of 7 remains 1 plus I 4 all over 5 into 2 to the power of 5 should be 32. 2 to the power of 5 is 32 minus 1 to the power of 5 remains 1. So I have this. Okay, so let's evaluate all at once. 8 minus 1 is 7. 7 times 1 over 3 remains 7 all over 3 minus, here I have 128 minus 1. That gives me 127. 127 times 3. 127 times 3 gives me 381 all over 7 plus, similarly, 32 minus 1 is 31. 31 times 4. So that gives me I 124 divides by 5. Okay, so I can evaluate here now. So we consider the LCM between these two. Let's just take LCM and put them in fraction. Now the LCM between 3 and 7 is simply 21. So we have 21. 21 divided by 3 is 7. 7 times 7 gives us 49. Minus 21 divided by 7 is 3. 3 times 3 is 1. So 3 times 3 is 1 gives us 1, 1, 4, 3. I have this plus I 1, 2, 4 divided by 5. So we now obtain 49 minus 1, 1, 4, 3. So that gives us minus 1094 all over 21 plus I 124 divided by 5. Okay, so you can either choose to leave your answer like this, or you can as well break it down to decimal places by just dividing. Okay, so but then this becomes the integral around the curve when x is equal to t and when y is equal to t3. Alright guys, so that's the idea behind integration on a complex plane. I hope the video is helpful to you. If you like this video, please do well to, of course, like, share to your friends, subscribe, of course, and of course, I would like to get your thoughts as well in the comment section. I will see you in this video. Thanks and cheers.